All right, so we're going to be talking about units of measure. So how do scientists measure stuff? So in order for scientists to come up with conclusions and determine answers and things like that, they have to be able to make measurements of what they're testing. So let's talk about what a unit of measure is. A unit of measure is any defined quantity that's been adopted by a group. So, for the longest time, feet, as in feet and inches, like what we use, was actually somebody's foot, like originally. That's what they would measure heel to toe on something and say, oh, that's 5 feet. And then it became a standardized unit, and so a foot was the same for everybody. Once it was realized that one person's foot isn't the same as the other, and we need to be able to measure the same. And I like this picture here because it shows many different ways that a hand has been used for measurement. So, how wide a finger is from one knuckle to the tip, how wide the hand is, the palm, how wide the hand is with the thumb, how wide the hand is with it completely out from tip of thumb to tip of pinky. So here's kind of 5, 6 different ways that there's been a unit of measure used from just the hand. But any shared defined quantity that has been adopted by a group is a unit of measure. So the unit of measure that is used in science is called the International System of Units. It was originally developed in France, and so therefore it's the System International des Units. That's why it's SI, S right here. S right here, and then I, right, versus IS as if it was in English. And what this was originally proposed and adopted worldwide was it gave all scientists, no matter where they were, the same measuring system. Okay, so if a marine biologist from Japan was measuring the size of angelfish and shared that information with the world, a scientist in America who also measures angelfish would have the same units, would know roughly, how big is that type of thing. Okay, so no matter where they are, they use the same units of measure, and it allows them to better communicate their information so that their findings can be replicated and confirmed. There are 7 standard measurements in the SI system, and then all other measurements are based off of that. Okay, so let's look at those measurements. So anything that is measured in time, the base unit is seconds, but it can go from there. But usually everything is per second, or sometimes they get into minutes, but 1 minute is just 60 seconds. Time is kind of the one of the units that are not base 10, okay, because there's 60 seconds in a minute, 60 minutes in an hour, and so on. Kelvin, which is a temperature range different than Celsius or Fahrenheit. This is based on the fact that the idea of absolute zeros. So the coldest anything can get is 0, and everything kind of moves up from there. We're going to use Celsius just because it's easier for us to measure, but this is the base unit for temperature in the SI system. Length is the meter, okay, and then you can have centimeters, millimeters, so on and so forth from there, but kind of the standard is the meter, and then everything gets bigger or smaller from there. Right? Mass, it's the kilogram, and then we can go grams, milligrams, centigrams from there. Okay, the amount of a substance, right, is the mole, and in chemistry we'll talk about what a mole is and what it represents. Electric current is the ampere, so that's how much electricity is flowing through something, and then how bright or luminous intensity is measured in candela. Right? And then everything is based kind of off of these things. For example, speed would be meters per second. I'm trying to think of other things. Pressure is the amount of mass, kilograms per square meter, right, would be pressure, and that is pascals. So everything is kind of derived from combining all of these and different. Some other common units used, especially that we'll use in the lab, but aren't part of the SI system necessarily. Liters. So this is a volume that we can use. So liters, milliliters, all that stuff is commonly used, but isn't part of the SI system. Volume in the SI system is actually measured in cubic centimeters. Okay, so cubic. And kind of a fun little side note is if you watch medical shows such as like Grey's Anatomy or something like that, and you hear them say, you know, give me 50 cc's. Well, cc stands for cubic centimeter, right? And so they want 50 cubic centimeters of something. Right, and so in the medical world, a lot of dosage volumes are measured in cubic centimeters. Okay, and like I said, kind of fun side note, 1 cubic centimeter is equal to 1 milliliter. Okay, so 1/1000th of a liter is equal to 1 cubic centimeter. So they are related to each other. Grams per cubic centimeter, which is density, and we'll talk about that, or grams per milliliter. The concentration of something, so you know how strong is your Kool-Aid, can be measured in molarity. Energy, so the amount of work that can be done is measured by newtons times meters, and a newton is kilograms per meter, I believe, if I remember right. Then temperature, like I said, we're going to use is Celsius. That's kind of temperature in the metric system. It's base 10. But it's not the SI unit because basically it doesn't get cold enough. And then in the SI system, as well as the metric system, they have prefixes that help us determine the scale that we're looking at. Right? And so these prefixes are based on relations of 10 or powers of 10. Right? So there's kilo, hecto, deca. Right? These are bigger ones. Then there's your base unit, and then there's deci, centi, and milli. Okay? So a kilogram, a hectogram, a decagram, a gram, a decigram, a centigram, a milligram. And so a mnemonic device that you could use to remember these things is King Henry died by drinking chocolate milk. Sometimes you'll see this with King Henry died unexpectedly, so UN, right? So unexpectedly drinking chocolate milk. And that's because some people say base, some people say unit, okay? And so it's either a B or a U. But mnemonic devices are a great way to remember the order of things. But we will have a prefix chart that we can use to help us convert. And that's connected here in the PowerPoint. And so we have our base unit right here, and then we have everything larger, okay, and then everything smaller. And you can see here that it's based off of units of 10, okay? So a deca, right, is 10 of the base unit. So 10 grams is equal to 1 decagram. Okay, hecto is 100, so 100 grams is equal to 1 hectogram, right? And kilo is 1,000, right? 10 to the third. And so 1,000 grams is equal to 1 kilogram. Okay, and then going the other way, these are moving the decimal place in the opposite direction. So 1 gram is equal to 10 decigrams, which is equal to 100 centigrams, which is equal to 1,000 milligrams. Okay, centi meaning 100, mil meaning 1,000. Okay. And we'll talk about this more when we talk about conversion. So because the SI unit is based on powers of 10, so again we're seeing here with not as much information, we can convert between prefixes by just moving the decimal. So what do I mean by that? Okay. So first off, the measured quantity that we're using does not change. So for example, here it's 1 kilometer or 1 kilometer, depending on how you want to say it. It's always 1 kilometer. Now, 1 kilometer is equal to 100,000 centimeters. but the measurement's still the same. So if I had 2 kilometers, this would be 200,000 centimeters. Okay. Only thing we're doing is we're changing the scale, okay, the scale at which we're measuring. Okay. So for example, 24 inches is 2 feet. It's still the same measurement, right? It's just a different scale, either inches or feet. Same thing here. Still the same measurement, but the scale is different. Kilometers, centimeters. So if we're going to convert from one prefix to another, the only thing we have to do is simply move the decimal point. So if we're going from a larger prefix, such as kilo, to a smaller prefix, such as centi, okay, we're going to move the decimal place to the right. Okay? And the way that we can determine that is we look at the difference between the two. So if I had this setup here, which you remember King Henry died unexpectedly drinking chocolate milk, right? That gives us this. There's 5 spaces or units or prefixes, right? 1, 2, 3, 4, 5 between kilo and centi. Right? And so I move the decimal place 1, 2, 3, 4, 5. And so that leaves me 100,000, right? Because it's 3 zeros, comma, 2 zeros, 1, right? It gives me 100,000 centimeters per kilometer. So you just move the decimal place simply to the right. If we go back and look at our prefix chart, we can see it here as well. Let's zoom in. Okay. So right here is kilo. So right here is kilo. Right? That is 10 to the third. Right here is centi, and that's 10 to the negative 2. So from here to here, that's the 3 powers of 10. Ooh, it undid my 3. That's 3 powers of 10. From here to here, that's 2 powers of 10, right? Because I'm looking at this number right here. All right? I'm looking at this number right here. And then 3 plus 2 gives me 5. And you'll get one of these charts, but what it shows us is if I'm moving up the chart, so let's say I'm going from zepto to pico, okay, that's moving up the chart. I move the decimal place left. So if I had, let's say 100 zepto, which is Z, and I want to convert that to pico, which is a small p, I'm going to take the decimal place, in this case it'd be right here, and I would move it, let's see, the difference between, ooh, that's a lot. Let's go to Atto, just because it's not as big of a jump. But the difference between 18 and 21, so 18, 19, 20, 21 is 3. Okay, so the difference between here and here is 3. And I'm moving to the left because I'm going up the chart. So then I move left 1, 2, 3. And so 0.1 atto is equal to 100 zepto. And if I'm moving down the chart, so let's go from, let's see, I'm trying to scroll. There we go. Let's go from, sorry, trying to make up my mind. Well, let's go from pico to femto. Okay, so we're going from here to here. Again, the difference is 3. Let's say we have 5,000 nano, which is an N, to, oh sorry, pico, and we want to go to femto. We're moving down the chart. So down the chart, move the decimal place to the right. Well, here's my decimal place. I move it to the right and I move it 3 spaces. So that's 1, 2, 3. Okay. When you move the decimal place and there's not numbers there already, you fill it in with zeros. So then this would be, so we started off with 5, 0, 0, 0. We moved the decimal place to 3. And since there aren't numbers there already, we fill them in. 1, 2, 3. Okay. And my prefix is femto. Femto. All right, and then that's 5 million femto. So if I had 5,000 pico, that's equal to 5 million femto. Hopefully you're getting this idea. We will practice it some more. So again, if we are going from a larger prefix to a smaller one, we move the decimal place to the right. And so here's an example. If we convert 35 kilograms to grams, right? Grams is smaller than kilograms, so we'd go from a larger unit. We're going from a larger unit, kilo, to a smaller one, grams. Right? And the difference between kilograms and grams is 1, 2, 3. And so since we're going from a larger unit to a smaller, we move to the right. We move 3 places because kilogram is 10 to the 3 or grams is 10 to the 0. And we move 1, 2, 3. So 35 kilograms is equal to 35,000 grams. If we're going from a small unit, such as centi to kilo, we move the decimal place to the left. I covered that already. So for example, if we have 5,000 milligrams and we're going to centigrams, so from milli to centi is one movement, okay, we move the decimal place 1 over. So 5,000 millimeters is equal to 500 centimeters. Okay, going from 10 to the negative 3 to 10 to the negative 2. Hopefully that was helpful. Again, just to review, if you're moving up the chart, so I'm going this way, and prefixes, I'm moving the decimal place to the left. If I am moving down the chart, so I'm going this way, then I'm moving the decimal place to the right. And then these numbers here gives you how many you need to move. Now, we can't simply count the spaces. Because here, sure, 1, 2, 3, but then this becomes 3 by itself. Right? So I can't just say 1, 2, 3, 4. Okay, it's 4 spaces. It's not. We're looking at, ooh, that was weird. We're looking at these numbers here. The difference between these two is 3. The difference between these two is 3. So if I was going from milli to nano, right here I'm drawing a 9, but it's really a difference of 6. And I would move my decimal place to the right. I hope that was helpful. Have a good day.